Hephaestus utilizes two Foxeer Falcor cameras, four Talon FAF 2207-2550 kV motors, a Mamba F40 4-in-1 electronic speed controller, a Lumineer Lux F7 flight controller, a FreeSky RXSR radio transmitter, an AKK race video transmitter, an Adafruit 5-volt electromagnet, a Xylo Pit Pal, Gemfan Hurricane 5146 propellers, and a Race Day Quad 4-cell 1800 mAh 16.8 volt battery. The whole drone was designed in Siemens NX 1899. We went through about 4 design iterations before deciding on one design. We switched materials from acrylonitrile butadiene styrene to polyethylene terephthalate glycol, and then finally settled on carbon fiber infused polycarbonate for the main frame of the drone. We knew from the start that we were going to use thermoplastic polyurethane for all the camera mounts and extra electronic mounts for its flexibility and shock absorption. All design parts were 3D printed on a modified Creality CR10. It took about 32 hours to print all 6 parts. The drone is controlled using a FreeSky X9D radio transmitter. The drone is programmed through software called Betaflight to respond to the radio transmitter's 6 auxiliary switches. The first switch arms and disarms the drone. That switch changes the drone's flight characteristics. That switch controls the camera feed. That switch controls turtle mode, which allows a pilot to control 2 motors to self-right a drone after it is flipped over during a crash. That switch turns on the Xylo Pit Pal, which itself was programmed in the CLI of Betaflight to control the magnet. While the drone has an arm-disarm switch as well as a failsafe protocol in case the pilot loses control of the drone, we have incorporated 2 kill switches to our design, one controlled by the radio transmitter and the other located on the drone itself. Pulling that plug cuts all power going to the drone. The remote kill switch is an auxiliary switch on the radio transmitter. It controls a servo on the drone, which allows it to pull a wire and disconnect the power, much like the physical kill switch does. Here's a closer look at how the remote kill switch operates the servo to disconnect the power. While the drone weighs about 768 grams, it can reach speeds of up to 83 miles per hour. To view the video feed, we will use the SkyZone O2C FPV goggles with Foxeer Pagoda Pro omnidirectional antennas. This is the pilot's view while wearing the FPV goggles. The text on the screen is from the drone's on-screen display. It relays crucial information for the drone pilot to operate safely. This test was performed outside of the drone pilot's residence and complies with all FAA rules and regulations. As you can see, the drone is still very agile despite being twice as heavy as regular FPV drones. This is due to the fact that we utilized Betaflight's PID tuning functions to help smooth out the drone's operations. At full stick deflection, the drone can yaw or rotate left and right 644 degrees per second, pitch forward and backward at a rate of 587 degrees per second, and can roll left and right at a rate of 552 degrees per second. Now, we'll watch the payload pickup process. The payload is a 1-inch cube 3D printed in PLA with a ferromagnetic steel washer on top of it, as outlined in the competition rules. We start by arming the drone, changing the camera feed, changing the flight characteristic, turning on the magnet, and then carefully taking off towards the payload. As you can tell, the drone's flight characteristics has changed a little bit. That is because the pilot has switched from flying in acrobatic mode to self-leveling mode. Once the payload has been picked up, we carefully land, switch back to the regular flight modes, and then continue on. While the magnet has a holding force of 15 kilograms, which is 150 times stronger than it needs to be, the pilot still flies with care to ensure the safety of the payload. Let's fast forward a bit. Now the pilot has entered the payload drop-off process. Being careful not to fly into the tree branches, the pilot flips an auxiliary switch, which controls the Pit Pal to turn off the magnet and let the payload drop. Hephaestus is expected to be able to finish the 5-lap payload pickup drop-off course in about 7 minutes, which is half of the allotted time. Hephaestus was designed to be fast and efficient while providing the maximum amount of safety possible. Stay safe, everyone.